Okay, it is essentially 12 o'clock, and welcome to this week's Iowa Learning Farms Conservation webinar. It is great to be back as moderator after I missed what seemed like almost all of September from moderating, although I did have to present once. And really looking forward to our speaker today. We have Dr. Emily Heaton, that's a professor of regenerative agriculture and crop sciences, an affiliate professor in agronomy at Iowa State. So she's a professor at the University of Illinois now, but she was at Iowa State University for a number of years. We were sad to see her go, but she's doing great things at the University of Illinois. And today she's going to be talking to us about using advanced biomass crops as regenerative ag tools to diversify the Corn Belt. So with that, Dr. Heaton, the virtual floor is all yours. As always, if people have questions, please type those in the chat box.
Thank you so much, Matt, and it is an absolute pleasure to join you here today. So I'm going to say a little bit about that transition to from Iowa to Illinois, but let me start by seeing if the slides will advance. That's always a plus. Here we go. So this is another version of a title slide here. I'm going to talk to you about using advanced bioenergy crops in the Midwest, but I'm also going to spend a decent amount of time telling you about our regenerative ag initiative, iRegen, as a mechanism and an umbrella to do that. So just to get some things going in the chat, you might have seen my title is a professor of regenerative ag at Illinois, and that can mean a lot of different things. So I'm curious about, what does regenerative ag mean to you? And go ahead and put it in the chat if you would like to chime in on that loaded conversation. All right, so the context and background for the work that I'm going to share with you today is a journey across 5 states. So as Matt mentioned, I was at Iowa State University since 2008, and then I transitioned back to actually my home state of Illinois in 2021, and I've been working a lot in both states since then. So I'm in Ames about a week every quarter, and this is a picture of some of the lab members that are in our Iowa State team, now supervised primarily by Dr. Andy Van Lukey that you'll hear about. And the work that I've been doing at Illinois has been colored in large part by the Sea Change initiative that Dr. Lisa Schulte-Moore originated at Iowa State. So I've kind of taken the good word east, if you will, and using it to create new knowledge in Illinois based on the Sea Change framework. So here's a snapshot of my lab group in Illinois. We had a recent outing to Curtis Orchard. If any of you have ever been there while visiting Champaign, it's a great place at this time of year. And I'm going to tell you a little bit about some of the connections with Dr. Linda Prokopi's project led out of Purdue called the Diverse Corn Belt. And that's a project that spans Indiana, Illinois, and Iowa really nicely. So these frameworks that Linda and Lisa helped put together have really informed what I've started at Illinois, which is this thing called iRegen that I'm going to tell you about more. It's our regenerative ag initiative here. So before I get into some detail about iRegen, I want to tell you just a bit more about where the money comes from. Since I've started in regenerative ag, this has been one of my biggest questions. Who's controlling that conversation, and what are their interests? So I want to just disclose to you up front that my money comes largely from a Department of Energy project called the Center for Advanced Bioenergy and Bioproducts Innovation. I'm going to tell you more about that, particularly when we talk about advanced bioenergy crops. And then a lot of the work that I'm going to tell you about is funded by the Diverse Corn Belt. Actually, I'm not going to talk that much about it today. And we have partnerships with a lot of different groups that we have some shared work with. Another big portion of the funding for iRegen comes from this thing called the Midwest Regenerative Agriculture Fund. And that's funded by a consortium of private foundations, many of whom are listed here below. So these are, some of them are national, some of them are Chicago area, and some of them are what in Illinois we call downstate, things that are not Chicago based. And together they've come together to make this Midwest Regenerative Agriculture Fund. So what is iRegen? It is a Midwest Regenerative Ag Initiative. It was supposed to be an Illinois Regenerative Ag Initiative. And I convinced them that that's dumb, that anything that we do in Illinois needs to be informed by and informing the work that happens, particularly with our river partners in Iowa and Indiana. So we've worked really hard to make sure we have a regional focus. And when I think about what regenerative ag means, there's a lot of principles of regenerative ag, but to me, everything came down to regenerating health and wealth. So in iRegen, we have it's of course an agricultural-based thing, but what's indicated in this very small and hard to read schematic at the top is that agriculture controls everything in my world. So what I mean by that is, agriculture mediates the flow of sunlight energy through the globe, right? Through the biosphere, through plants, through animals. And because of that, it influences our food supply. Because of that, it influences our economic systems, our health systems, our social systems, our political systems. And so two of the sort of foundational principles around regenerative ag seem to be health and wealth of those systems. Are they keeping the system functioning, and are they improving outcomes for people, communities, ecosystems in those systems? So why particularly does iRegen exist at the University of Illinois? Here is a schematic showing relative investment in technologies based on the quote unquote readiness of that technology. So is it a concept that has been just proven? Has it been validated? Is it demonstrated in the field, or is it deployed at commercial scale? And what we find is that universities like Iowa State and Illinois and Purdue do a good job of supporting or getting funding for new technologies. And industry does a good job of deploying technologies that are already proven. But in this country in particular, we've really not funded this middle area. And so we've seen a lot of new technologies that have not come to market or been deployed in the US the way they have in other countries because we don't fund this gap in between. And so iRegen is really aimed at bridging this innovation to translation gap. And we know that there's not a lot of money to go around to do this in the regenerative ag space. So we have a portfolio that includes government money that are, like I mentioned, Department of Energy and USDA funding, industry money, institutional money like the University of Illinois has put in, and philanthropic funding like I mentioned with these private foundations. So let me tell you a bit just about the goals of iRegen. They are really aimed at helping the University of Illinois show up in the regenerative ag space. There's when I came here and I grew up here, so I can say this. There's a perception that the department or the College of Ag at Illinois is sort of bought and paid for by big ag. Iowa State and Purdue suffer from the same perceptions sometimes, even though we've done some really amazing work that could help change the paradigm of big ag or big food or big pharma. That perception persists because we do have good relationships with industry at these universities. So iRegen is really aimed at helping build capacity within the regenerative ag framework at the university, reduce fragmentation within the communities. The non-governmental organizations in more populated states are prolific. There's a lot of them, and they're all perhaps giving slightly different messages to stakeholders like farmers or regulators. And then one of the goals of iRegen is also to leverage resources that we can use to bring to bear on translating regenerative ag ideas into practice. And we do that, we go about achieving these goals by deploying our science with partners. And so what I'm showing here in this figure on the left is some work that Lisa and I and others did at Iowa State looking at subfield profitability. So this is a paper, it's hosted on the agronomy Mesonet site, but we had a series of papers that estimated how profitable different parts of fields were. And this is an image shown from 2015 when the profitability of corn and soybeans was down as input prices caught up with falling commodity prices. And we're in a similar situation today. So how can we intervene on some of these most unprofitable acres with more profitable strategies to improve the overall wealth of our communities? And then this figure on the right should look familiar to many of you. This is from based on data from the Iowa Nutrient Reduction Strategy that indicates that we've known for a long time that some of our perennial strategies like pasture or CRP or perennial energy crops like I'm going to talk about are some of the most efficacious ways to reduce the nutrient load of nitrogen and phosphorus to our waters and thereby increasing the health of our ecosystems and our communities. So these are, some of the principles that we put together and deploying the science into action. These are key ideas behind the regenerative ag portfolio in Iowa as well as Illinois. One way that we're going about deploying the science is by leveraging our existing assets. And so what I'm showing here on the left is an aerial view of the University of Illinois' South Farms. So this is our research farms just south of campus, as the name implies. We're not too creative. And this is an amazing resource. So there's almost 3,000 acres directly adjacent to campus that we use for our research. And a lot of it is in bulk corn and soybeans between research experiments. So it's being used to fund the research enterprise at the university while it's in cash crops. And this is similar to how it's done at Iowa State and at Purdue. You'll notice that in this top box here, these fields are managed by different departments. So if animal sciences in yellow and crop sciences in sort of pink and red, we have horticulture as part of crop sciences at Illinois. But all of these now are under the management of the crop sciences field team. So this is really nice. We have one managing unit who controls the land, and they've been great partners. So we can think about how we can use our own land to share what might otherwise be sensitive information like profitability on parts of fields. So no farmer necessarily wants to share this with all his friends, but the University of Illinois can. We also, this is a picture of us having a field day last year at our energy farm, which is a site that's unique in the Midwest, although Iowa State has one sister site that's analogous to it. So we can start sharing our work at our fields. And then this figure here shows that we can leverage our financial assets, our land assets, and our human assets. So we've been able to, as I'll tell you in a minute, get partners from around the university itself to deploy resources into iRegion. All right, so who was on the iRegion team? Well, as we already said, I'm the director. Anya Connect is the assistant director here. Some of you might know Talon Becker. He's extension specialist here at the university and is our extension lead within iRegion. And then recently, we've brought on the SARE Illinois coordinator, Kate Loomis. If you go to the SARE website, it will say that I am the Illinois State SARE coordinator, and I'm happy to answer any questions you have about SARE, but I will ultimately direct you to Kate, who is shown here in this picture. And we've partnered with SARE to have a dedicated person for SARE questions so that we can start connecting the work that we do at the university with the work that's done at the federal level through SARE. And if you're not familiar with SARE, it's the Sustainable Agriculture and Research and Education Program from the USDA. It's an amazing program with amazing resources. They do fund small grants for people throughout the North Central region. We've also brought on a dedicated extension employee. This is Bina Pegg, and she works directly with Talon to help expand our capacity within the regenerative ag space at Illinois. And then we have an extension fellowship program. So if you're familiar with Nathan Johanning, he's another extension specialist here. From an institutional perspective, we have buy-in from all levels of administration. So I just thought it was important to tell you that our Vice Chancellor's office, our Chancellor here is similar to the President at Iowa State, our Deans of Extension, the head of my department, and then Director of our Sustainability Institute on campus. So these are some of the people who help control the direction of iRegion and then share what we're doing at all levels of the institution so that the institution is aligned behind these same goals. And then I just want to tell you a little bit about some of the things we're doing within these three goals. Then building capacity. I mentioned we were using our land base to I guess, walk our talk. You know, if we talk about strategically deploying perennials or strategically integrating perennials into farmland, it's important to be able to understand the pitfalls associated with that. And so what I'm showing you here in this figure in the top right, this is a student who actually just defended yesterday, Killian Delaney, with executives of Victoria's Secret. So Victoria's Secret is really interested in making sure that their cotton and ultimately all their fabrics come from sustainable sources. So they've been sourcing cotton from Larkin Martin. Many of you might have heard of Larkin. She's a farmer in Alabama, but she's very influential in multiple agricultural circles and sits on the Kansas City Federal Board of Trade, or sorry, Federal Reserve Board. So she's got her fingers in a lot of different things, but she supplies about 10% of the cotton for Victoria's Secret right now. And they've come to us to understand how to think about the ecosystem service and financial impacts of doing that. So we've been working in a really nice partnership with them. And then I'm just highlighting Graham Bishop here. Some of you might know his dad, Dave Bishop. He's a big regenerative ag producer in Illinois. And together with some other scientists, we've been working on digitalizing the data from the South farms, from our research farms. And this is led by Dr. Nico Martin at University of Illinois in Crop Sciences, so that we can have a platform for not only collaborating better on campus, but demonstrating transparency and reporting, particularly of ecosystem services. I think we're all a bit concerned and skeptical at times of programs that want to use farmers to provide offsets or insets to greenhouse gases. And so what we're aiming to do at Illinois is use our own farms to do that, so we understand and can demonstrate those pitfalls to others. And if it's profitable, then we'll make more money for our own ag enterprise. So we'd like to understand if we can use ecosystem services as a way to provide unrestricted recurring income for the research farms, because they're not really supported by state governments anymore. We're also building capacity in other types of living laboratories, not just the farms. And so what I'm showing you in this figure here is work, we're blessed at Illinois that we have a medical campus, and we have the collaboration between our area hospital and our College of Engineering. And so what we've done is to help build class programs with doctors and chefs to connect the way food is grown to human health. And so this has resulted in a few publications and a few classes. And actually now it's been incorporated into doctor training programs with Carle Hospital in Peoria. There's a variety of other things to highlight here, but in the interest of time, I'll just say we are working with agroforestry, as well with the Savannah Institute. And this graphic here on the bottom is indicating that the University of Illinois as a whole is shifting its investment portfolio into regenerative ag carefully. I mean, the university is always very careful with its money, but it's been a partner with, or a pilot partner with BlackRock, which is a major global investment advising company, about how to use the endowment farms as a way to not only generate the income on which the university depends, but also to make sure that we're investing in practices around the world that support regenerative outcomes. So we advise the university financial office on that. One thing to note about that health program is that it's actually in partnership with Iowa State Extension on creating farm to institution value chains that include the National Guard, in case any of you are involved with that work. And so here's Aaron Meyer, the lead on that for Iowa State, or sorry, for Basil's Harvest that works with iRegen. Some of you might also be familiar with the Idea Farm Network that Will Glazik leads. So I think some of you work with Dallas Glazik as well. And we've also been supporting work on training extension faculty and staff on what's involved with organic operations as organic has become more profitable, or the profitability has become more challenging in recent years. And that leads me to this last kind of collaboration slide. I mentioned there's lots of NGOs in Illinois, and there definitely are. So you have this thing called the Illinois Sustainable Ag Partnership that includes a lot of the NGOs that I just mentioned and more. So there's 19 different partner organizations, of which Extension is one. And so this is some of the ways that we get our science deployed is through these partner organizations. I just want to also highlight that I mentioned we have institutional support, we have federal support from the College of ACES, from the Chancellor's Office, and then from multiple institutes on campus. So I've been really pleased since I've arrived at Illinois that we have a lot of institutional buy-in that's oriented towards regenerative ag, and have been able to make some progress quite quickly. So I'd like to switch gears now and say a little bit about those advanced biomass crops. So I mentioned at the beginning the Department of Energy. So this is now work that's part of CABI, the Center for Advanced Bioenergy and Bioproducts Innovation. And I want to particularly highlight here that I have many collaborators in Illinois, but since this is the Iowa Learning Farms presentation, I've worked closely now with Dr. Andy Van Lukey since 2014. We co-advise several students together. This Dr. Marshall McDaniel, soil health and plant and soil science specialist in the Department of Agronomy, and of course, Adina Howe in the Department of Ag and Biosystems Engineering. So we've collaborated together on these projects since 2017, and I'm excited to share a little bit about that with you. But first, what is CABI? I mentioned it's a center. The purpose of the center is really bioenergy focused. It's a Department of Energy center. So it's meant to provide scientific discoveries and new technologies to develop an economically viable and environmentally beneficial biofuel and bioproducts in our industry. This bioproducts bit is relatively new for the Department of Energy. For those of us who are active in the bioenergy space, we know it's prone to booms and busts. We're still dealing, in my opinion, with many of the fallouts from the 2006 through 12 biomass boom, our biofuels boom, when ethanol corn acres really expanded. And now we have, some unintended consequences, particularly environmental unintended consequences, but also economic and unintended consequences of that policy. At the same time, we're facing, a lot of the same messaging that we heard during that time again, but now oriented towards sustainable aviation fuel. So I'm happy to talk with you about those things if you're interested, but I thought in the interest of time, I would give you more of the scientific foundation for how we make those fuels. Whether or not they go into aviation fuel or to a bioproducts industry. And as I mentioned, bioproducts is relatively new for the Department of Energy because they have recognized after sort of the last ethanol boom that it's not smart to put all of your market eggs in one basket, and bioproducts help diversify market opportunities from some of these crops. Let me tell you a little bit more about the partners involved in CABI. It's a rather huge center. It's led at the University of Illinois, where we have about half of the faculty involved. There's 58 faculty level researchers, and then about 300 other people that work on the project across these partner institutions. And so they are concentrated in the rain-fed United States with scientific expertise from the coasts. Now within CABI, we do something a little bit different with crops. So what I'm going to do is walk through this schematic. What you're seeing here on the right are some of our icons for some of the things that we can create from plants within CABI. So I mentioned sustainable aviation fuel and ethanol, but some of those products include everything from detergents, paints, adhesives, plastics. I think we're up to like 30 patents now out of CABI science. And we're currently, for example, in conversations with Procter & Gamble over an invention recently that makes a nice absorbent substitute. So if you think about diapers, Procter & Gamble makes a lot of those. And some of the compounds that we make in CABI now are really nice alternatives to fossil-based absorbents that are in baby diapers. So the way we think about bioenergy and bioproducts in CABI is first through a sustainability lens. And this is where Andy Van Lukey and Adina Howe and Marshall McDaniel sit. They think about the environmental and economic consequences of using bioenergy crops, everything from the field to the landscape scale. And this is where some of my work fits too, that I'll mention in a second. I lead this feedstock production theme with colleagues, and our goal here is to develop resilience traits and, importantly, oil traits in these crops. So we have miscanthus, sorghum, and sugarcane as our focal crops within CABI. And these are all sort of kissing cousins of each other. They are interfertile, and we can use a lot of the same genomic resources to improve them. Uh, from these crops, we can process them directly into fuels, but we can also process them directly into high-value chemicals like those diaper absorbents that I mentioned. And this was done with our conversion theme. So our conversion theme focuses on developing engineered yeasts, so novel yeast, not the baker's yeast that you're familiar about with normal fermentation, but these are oleaginous yeasts. So these are yeasts that like to make oil. And there is a focus on oil in CABI in part because that's what the marketplace is demanding now is oil substitutes that can be drop-in fuels for things like sustainable aviation fuel. We still have sugar platforms that could make things like ethanol, but really oil is the high value product that we anticipate that our CABI crops can make directly in the plant itself. So to tell you a bit more about that, I'm going to zoom in here on the feedstocks production theme. And we have 5 goals within this theme. A lot of them are around the basic science of manipulating CABI crops, so stem biology, genome biology, but we also have work that's focused on, for example, high throughput phenotyping. If you think about breeding new crops, crops that are not traditional crops for grain, we really need to be able to get information about them quickly so that we can improve key traits quickly. We also have goals in the theme that are directly focused on getting oil production, specifically triacylglyceride production in the stems of the plants themselves. And so if you think about this, this lets you get to a point where you have, for example, a sugarcane plant. So here I'm going to show you some of the progress that we've made converting sugarcane into what we call oil cane. And this is done through metabolic engineering. So this is genomic engineering of these crops using developing new technology to create it. But what you end up with, if you look at this figure over here on the right, this is a wild type sugarcane, so normal sugarcane. And next to it is our first generations of oil cane. And you'll notice that they're shorter, they're smaller, and that's just because we're not good at growing oil cane yet and breeding it just yet. But if you look at this figure here, this is the percent of leaf dry weight that's in an oil compound, so triacylglyceride or just the total fatty acid. And if you look at the wild type here, there's a little bit that's naturally produced in sugarcane, but in the oil types, we have dramatically increased amounts of oil in sugarcane. So what this means is that you can go to a field, they're chopping down some oil cane stems here, weigh it, put it directly in a juicer shown in this little inset here, and you get out a sugar stream, you get out a juice stream, and that is sweet, greasy water. So you can think of this sort of like Italian dressing or Catalina dressing, and you centrifuge that and you get sugars on one side and you get fats on the other side. And we're also doing this with sorghum. Interestingly, we're also able to do it with miscanthus, but I'm going to shift gears quickly. I'm running low on time and tell you a bit about some of the work that has happened with miscanthus in particular. This was me during my graduate days before I went to Iowa State. And that's around the time that Carl Bernanke started measuring the exchange of carbon from the crop to the atmosphere within miscanthus and other crops. So what I'm showing you here on this y-axis is called net ecosystem exchange measured with eddy covariance, which is a gold standard measurement for measuring this stuff. Anything above this 0 line, this dashed lines, means that the whole cropping system is a source to the atmosphere. Anything below that 0 line means it's a sink of carbon from the atmosphere. And each one of these little squiggles represents a growing season. So if we look at this orange line here, maize 1, this is where the corn starts growing in the year, and this is when the crop is, this is when the crop is growing during the year and it's drawing down carbon, and then it releases some carbon back into the atmosphere. And if you add those up each year, so this is a corn, soy rotation, what you see is that over time, the corn soy system is a net source of carbon emissions to the atmosphere. And this is irrespective of looking at soil organic carbon changes. This is the whole field breathing in and out. At Ecovariance covers a 10-acre swath of the field. And if you look instead at switchgrass and miscanthus and native prairie, which is in purple here, they are net sinks from the atmosphere, and that increases over time. And so this is some of the key information that was not available to us before. And we have an analogous site that Andy Van Lukey runs at Iowa State showing the same thing. We've done a lot of work looking at miscanthus in prairie potholes like these here that have been planted to miscanthus. And now we're doing quite a bit of work trying to understand the consistent productivity of miscanthus in these underperforming areas of corn soy fields, for example. So where can we really increase the profitability of corn soy fields by strategically integrating this carbon negative crop? And then we think about where to sell that. So these are, I've already mentioned markets, particularly for cabbie crops in the liquid fuel space and the biochemical space. But some of the big markets are in poultry bedding. So in Iowa, a lot of the miscanthus is used for Tyson to have for turkey bedding. There's the University of Iowa Power Project is still going strong. I'll share that in just a minute. And then the packaging world is really exploding. Sustainable packaging based on grass crops is a rapidly growing market segment. Food additives are another one to watch. In particular, there's been positive microbiome benefits from replacing cellulose ingredients with miscanthus. I just want to finish by telling you a little bit about on-farm demonstrations. So I don't know if Steve is on the call today. I know he makes a lot of the Iowa Learning Farm webinars, but Steve Schomburg has been a great partner that we've worked with since 2013, I think. This is a picture that he sent last week, 2 weeks ago, bringing all our dreams together. So here's a miscanthus field next to a prairie field with strategic integration of perennials on his whole farm. So Steve does oak savanna restorations, he has pasture, but then he also has corn, soybean, and miscanthus. So he's diversifying his crop portfolio and then selling this miscanthus in particular into diverse markets, bedding, erosion control products, and heat and power. And he designed his fields based on the input from that paper that I showed you at the very beginning with the subfield profitability. In Illinois, one of the things we're trying to do is develop a biomass innovation hub. And so this is really, again, practicing what we preach. Our target is to have 10,000 acres of miscanthus starting to be planted anytime and used commercially, semi-commercially here on campus to make some of those products that I mentioned, bedding products, food additive products, packaging products. And the idea here is that, you know, we use some of the social science that's been developed, particularly Jay Harbuckle's work is very influential, but Linda Procopi's as well, about how we get miscanthus to be how we make sure that people want what we're offering and we're offering what people want. And then demonstrate Illinois-led growing, processing, and use that leads to industry transformation. And so this is, I just want to finish here by sharing a figure from one of Andy and I's recent students, Matt Nowatzki, who is often on these calls as well, published this paper with interviews from farmers, particularly in Iowa, highlighting opportunity for improved decision support systems. There's some really great quotes in this paper that people who are probably on this webinar provided, Matt, and I just wanted to say thank you for doing that. About how we could do a better job supporting regenerative ag transitions in the I-States. And then this figure here on the right is where I asked Copilot to give me a piece of art related to carbon intensity in agriculture. And I thought this was sort of interesting here. So windmills dominate our landscape, solar panels dominate our landscape, wheat's making a comeback. All that seems pretty accurate. In my home county right now, I don't bring up solar panels or wind panels unless I'm looking for a good fight. I'm not sure where this food came from. I don't see any of it produced on the landscape, but I feel like this is emblematic of some of our challenge and why we do the science that we do to help shape this path forward. So with that, I appreciate your attention and I look forward to your questions. But I'm going to pause here to ask Elena if I should move forward with the certified crop advisor slides at this time.
Yep, you can um, move forward. So if you watch this webinar live and need to earn or want to earn a CCA CEU, send your name, the name you entered to watch the webinar, and your CCA number to Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today. Again, your name, the name you entered to watch the webinar, and your CCA number to Elena Whitaker, ALENAW at iastate.edu. If you watch this webinar live and are willing to fill out a voluntary demographic survey, we would greatly appreciate it. You can scan that QR code that's on the screen, or you can go to iowalearningfarms.org/survey. If you've done one for 2024, thank you very much. And you don't need to do another one. But if this is your first webinar, or if you haven't done the voluntary demographic survey and are willing to do so, we'd greatly appreciate it. Okay, let's go to, I think, we have next week, excuse me, Megan Anderson, that's an extension field agronomist. We'll be talking about water hemp is killing us, but can cover crops save us? So if you're interested in cover crops and weeds, please tune in next week to Megan Anderson. And I think there's a last slide. This webinar will be archived on the iowalearningfarms.org website, or you can go to YouTube and we have an Iowa Learning Farms webinars page playlist there. So either way, this will be archived there. So we did have a few questions come in, and maybe the first one is, what about hemp as a feedstock?
Hemp is a great feedstock, and I would be remiss if I didn't mention that DK Lee at Illinois, who also works on biomass crops, among many other things, started a hemp certificate program at Illinois. It is subscribed. There's 1,500 students every semester, I think, in DK's classes, and so you can take that certificate program online if you're interested. It's a rigorous science-based training, and I've learned so much about it. We do have multiple hemp trials, both for medicinal and fiber sources here on campus, and many companies that are part of it. So I think there's, the market is evolving, of course, in hemp, but we have a lot of building materials that we use on campus from hempcrete, for example, and that fiber market is very exciting. Different than some of the grasses that I told you about. Since hemp is not a grass, the fiber structure is quite different.
Okay, hempcrete. Okay,
yeah,
that's
so
really cool. All right, that's exciting. Okay, next one, miscanthus is considered invasive, is it not?
The one we're talking about, Miscanthus giganteus, is not, and it's been monitored in Europe for over 50 years and the US for over 20 now. The parents of this species, though, can be a little invasive. And particularly if you're driving around between Iowa and Illinois, you'll see a lot of miscanthus in eastern Iowa in particular. And that's Miscanthus sacriflorus, one of the parent species of the one I'm talking about. This is an area of active work for us. We do have North America's largest miscanthus breeding program at Illinois. And, certainly we want to do no harm with any interventions we have in the landscape. I will say a lot of that miscanthus in eastern Iowa is purpose planted. And I did a decent amount of monitoring that when I was at Iowa State. It has not moved that much, but Sacriflorus was taken out of the Iowa State Botanic Garden, now Ryman Gardens, in the 40s because it was deemed too aggressive by the garden staff.
Okay. Next one, how do you get started on integrating miscanthus on a central Illinois farm? They indicated their local, grain and barge elevator may not be a buyer.
Yeah, first of all, you can reach out to me. We can have a conversation. Your also your county staff should probably have some information about this now. We're trying to do a better job of making sure they do. But certainly having a market and a distribution network is important and key before you would plant anything. And so we can help you think that through and whether or not you're in a good spot for that.
Okay, great. Kind of there. Got a couple science questions related, I think, related to the CABI site. So one was, were you able to look at N2O balances? And then kind of maybe related, what do you think is contributing to the carbon sink? Increased biomass or reduced soil respiration?
So talk with Marshall is probably the
Okay,
first
all right.
place to start. So
Okay,
Marshall's got a big team on this and he would love to
okay,
tell you all about it.
okay, okay. That maybe we'll have Marshall back for a presentation on that, and the two individuals that are asking are at Iowa State, so they can
Yeah.
ask
Yeah.
ask
Marshall and
Marshall.
Andy are the places to go. It's giant grasses take up a lot of carbon. And if you don't
Okay,
till them and they have below ground biomass, they put it below ground and they leave it there.
okay. Um, I guess another one is as you think about the regenerative agriculture and things being done maybe on the Illinois farms there to evaluate some of these things. What metrics are being evaluated? And I guess, yeah, how
That's
is
a
that going in evaluating some of that?
Yeah, so again, we want to regenerate health and wealth in these systems
Okay,
using perennials as tools, and do no harm is the first step of improving health. So we have a holistic number of measurements and metrics that we use, and the Oak Ridge National Lab has actually been key in publishing some really nice summaries of these metrics. Virginia Dale's group in particular. So they are biodiversity metrics, they are greenhouse gas metrics, they are soil health, water regulation. So, it's not
okay,
just good to have clean water if there's no water left because the crops use it all. So those two pieces go closely together. And then, there's a lot of unintended consequences that can happen for communities with these crops too. So we want to make sure that these are not polluting the air, for example. There's a lot of dust from these crops. So a lot of different metrics to consider. And I'm very grateful for Iowa State sociology for helping us think about those.
okay. All right. I think that helps answer most of the questions that we have time for today, and a couple that maybe will prompt us to get Marshall to come and talk about some of the, the in-depth measurements that are being done at the CABI site. I think we did a virtual field day at CABI
Yep,
one
that's
time. I
right.
think I remember, yeah, Jackie being excited about how excited the grad student was about the eddy covariance system. So,
It's right
uh,
across the street from one of the Prairie Strip sites
yep,
and right down from Bill's pothole site with the
the
controlled
wetland site.
drainage, so the
Yep,
wetland site. So yeah, it's a beautiful place to go explore if
yep.
you haven't already.
All right, Emily, as usual, thank you so much, and it's really great to hear all the work that's happening at Illinois and the support you're getting there for these efforts. We look forward to continuing to follow it.
Thank you so much for the opportunity to visit. And thanks so much for the descriptions of regenerative ag that you put in the chat. That was great.
Yep, we'll make sure we get those to you. Okay.
Have a great day, everybody.